Formation of ionic compounds. Ionic compounds, such as sodium chloride, are formed between a metal and a nonmetal. Sodium chloride forms a three-dimensional array of positive sodium ions and negative chloride ions held together by electrostatic attraction between opposite charges. Let's look at one atom each of sodium and chlorine. Sodium has a single electron in its valence shell, and chlorine has 7. Sodium's low ionization energy means that sodium can easily lose its single valence electron, leaving a positively charged sodium ion with a filled valence shell. Chlorine's high electron affinity makes it favorable for chlorine to gain an electron to become a negatively charged chloride ion. The transfer of one electron from each sodium atom to a nearby chlorine atom produces equal numbers of positively and negatively charged ions, each with a filled, stable valence shell. The attraction of opposite charges holds the ions together, forming the compound sodium chloride. The formula NaCl indicates the 1-to-1 ratio between sodium and chloride ions. Not all compounds have a 1-to-1 ratio of ions. For example, to form sodium oxide, the numbers of electrons to be lost and gained to achieve filled valence shells are not equal. Each sodium atom will lose one valence shell electron, but one oxygen atom can accept 2 more electrons in its valence shell. This means that to form a compound with a net charge of 0, 2 sodium ions, each with a +1 charge, are required for each oxygen ion with a -2 charge. The compound's formula is Na2O to reflect the 2-to-1 ratio between sodium atoms and oxygen atoms. The formulas of other simple ionic compounds also reflect the balance between electrons lost by a metal element and gained by a nonmetal element. Key takeaway.